Hello, welcome everyone. Good afternoon. If you hear my sound, please write hello in the chat just to be sure the sound system is working well. Hello, yes, hey. Yes, the system is working. We can wait for another 60 seconds and then we are ready to begin. Okay, everything is fine. All right. People are joining. I can see almost 20 people are in the call. In 30 seconds, we start. I see some more people are joining. All right. Good afternoon, everyone, and welcome to today's BM Process webinar in partnership with Kranz Clean Air Solutions. My name is Amol, and I'll be your host. Today, we will explore one of the biggest challenges for our industries, which is reducing VOC and methane emissions from different industries. With climate regulations tightening and sustainability at the top of every company's agenda, it's the perfect moment to dive into proven solutions and innovation. I'm sure you are ready to hear more from us. Before I begin, a bit of housekeeping. The webinar is being recorded. That means you will receive the replay by email later if you're registered. Please post your questions anytime in the question and answer section that you will see on the top. If you're on the phone, you will also see most probably at the bottom. We will answer them after the presentation. We will also have some short quizzes just to ensure that session is more interactive and you're also involved, because we don't see you, we don't hear from you. And of course, you can also see from your screen the attendees' names are hidden just for their own privacy. So keep an eye out for those on the screen or in the chat section. This is 1 hour of webinar. We would dedicate last 10 to 15 minutes focusing on the important questions that we would gather throughout the sessions. So I'm not going to read everything, but quickly to introduce our first speaker and the expert. Bart is a managing director of BM Process Management with over 2 decades of experience across engineering giants such as Jacobs and Fluor. Bart has dedicated his career to emission control and process engineering. Since founding BM Process in 2020, he has helped tank terminals and industrial sites across Europe tackle emission and stay ahead of tomorrow's regulations. Then we have Jutta. Jutta is a senior expert in thermal emission treatment at Kranz Clean Air Solutions with more than 3 decades of experience in designing energy efficient exhaust air purification system. Jutta has been shaping best practices in emission law and emission design across Europe. And we are excited to hear from her perspective on thermal oxidations and RTO solutions. So before we begin, and just to ensure that things are working well technically, by the way, we have really privileged to have both Bart and Jutta over half a century of experience in the field. I would like to put a quick quiz on the screen, and I'm looking for your participation. So you can see a very simple but important quiz on your screen. Let me launch. All right. The quiz is very simple. Who is currently the president of United States of America? You can click and see whether your system is working. Let's see. I'll wait for another 10 seconds. Last 5 seconds. And ready to submit the results. Oh, Mr. Donald Trump. Okay, our system is working well. 14 responses. Thanks for your participation. More than 80% of our participants responded. Now, let's welcome on the stage someone who you most of you know him personally. This graphic is just for the fun, but in real life, most people run away when they hear the word compliance, but not Bart. He runs towards it. He's the kind of person who, if you invite him to a party, he will find a quiet corner and start a conversation about emission control. And somehow, I'm telling you honestly, somehow you will end up listening to him. So please welcome on the stage our very own compliance hero, Bart. Bart, are you ready?
Thank you, Amol. Yes, I think I'm ready. So
Great.
Thank you for this introduction.
Over to you.
Yeah, so I'm glad that I can talk about this. Since generally they don't want to hear what I have to say, but here hopefully you do. So next slide, 10 billion. I want to start with that. And the main question that I would have for you is, and you can answer in the chat, what is it that you have in mind when you see this enormous number? Let's hear it from you. In the chat, please. And for anyone that thinks that that is my net worth, that is not true yet. I'm not Mr. Musk, so trying to do my best, but probably will not achieve that.
Okay, the population of Earth is a kg of VOC emitted annually. Let's see, Bart, who gets the surprise gift today. $10 billion fine every year.
That's a lot.
Okay, let's wait for one more answer and then we show it.
All right. I saw a few things in the chat, which I think the right answer is there. And it is with how much we will be on this Earth estimated in 2050. So that's a lot. As you can see, if I would be able to help you with housing, that would probably be my net worth, but it's not. I can't help you with housing. But what it does state is the fact that we have such a high growth rate will put an extra strain on all of the actual resources we have on this Earth. And since the air doesn't stop at the border, the global air quality is under pressure. So that's what I wanted to show here. So thank you for the right answer there. We can go to the next slide. VOC emissions globally. What are the 10 biggest that we have on Earth? You see them in this slide. We will generally talk about 2 of them only. But why do I say this? Is since we are growing on Earth and a lot is happening globally, we see that there's a shift between where products are made and where they are used. So to transport, ship, and store products is growing. And that is what we will actually talk about today. So we can go to the next slide. Emission and the effects of laws that we use. I want to show here, because you hear a lot in the world like, yeah, but it's only a small change. It won't help anything if we start to do this and that. I happen to pretty much disagree on that. Why? Because of the fact that we've got quite a few examples where it has been shown that it can actually work as long as we work together, which is at present globally, I would say, a small challenge, but let's just try and see the good things here. For example, number 1, the ones that still recall, for example, the rain used to be a problem, but we actually solved that. So that is one thing that we did solve quite well. So, for example, HFCs in spray cans that you all know had a real problem. Since we acted globally, that actual problem is gone. So that shows that it can work. Example 3 is the map that you see on the right. There you see NOx in Holland over not a very long year frame, let's say, and you see how it has actually gone down. So we can act even in such a small dot as we are over here in Holland. We're not that big, but still we can see it can work. The next, and even that is, I think, a main challenge we will have is the greenhouse gas and global heating up, let's say, and that's what we want to talk about a little bit more today. Can go to the next slide, please. I've got the slides here as well, so I need to make sure that I keep the same ones in front of me. Here you can see the actual thresholds that we have had over the years. And you can see that they go down, and they go steeply down. As per 2024, we go down a lot, at least here in Holland, in Germany, and so on. And that will be the case across over the next years. Now, what you see is that we made a big leap over the first time frame, and the leap is actually smaller. It might seem smaller. However, to squeeze every last drop out of these exhaust air streams requires much more work than it did to actually do the first big leap. But still, this is where we want to go and where we have to go. And this is why we are here to help. Because I think to squeeze the last drop out of all of this requires guys and girls that know what they are doing. What is also important, methane is excluded from what you see here. However, there's a lot about this happening at present, and we expect from 2030 onward, probably there will be laws that do apply to this as well. But we will talk about this, how you can also handle these emissions of methane over time. Now, let's go to the next slide. Emission sources and tank storage, because that's what we are here to talk about. Of course, this does apply to quite a few other things as well, but for now, we look exactly at this part. So there are actually 3 main sources. One of them is, of course, the tanks, because you store the product, you have, of course, breathing and so on, so you lose product there. When you load and transport the product in ships, barges, trucks, rail cars, of course, you have air that you have to treat, or there's air where there's actually product in it, which will have to be treated. And then we have the final one, which is fugitive emissions. We will generally talk about the first 2, because fugitive, that is another ball game. However, on that, we have a little quiz in the next slide, so we can talk about how do you think you need to treat fugitive emissions?
Nicht machen, bitte.
So there are a few answers possible here. So I would like to hear from you what you think is the way to treat fugitive emissions. Wait a second. See what you think. All right. I think those are all the answers. And should I click done now, by the way, Amol? Yeah, probably.
Yes.
I'm not sure.
It's
Okay, so we can see the results. You can see that in the chat.
57% things, measurement of reduction and reduction programs. Is it true?
Yeah, so you see here that there's a big part that thinks the programs as such are the actual way to go. I would say actually all of the 3 are right, except for the last one, but that's fine, because that's why we are here to help. There's also one that said, I don't know, it's really not my expertise, which is fine. So all of them count, actually, to ensure that you can reduce fugitive emissions. We can go to the next slide, please. I should do that as well, because I have it in front of me. So how to reduce emissions in tank storage? There's quite a few options we have. For example, floating roofs and tanks, or breather valves on tanks and so on, to ensure that we have not as much breathing losses. Then all the exhaust air streams, we can use treatment for them. That is option number 2. And option 3 is, as we just said, to ensure that you have a clear view on fugitive losses. Let's say you have to make sure that you know where they are. That is the first challenge. And then to ensure that you can bring those down. And there are quite a few options for that, as we previously discussed. So these 3 options are actually all in use as we speak. That is in use at all of, or at least at a whole lot of the clients that we work for. So what I want to note there is that this has gone down dramatically over the past 25 years. So this works. It works like a charm. That is like we saw previously with the actual thresholds. We did a big leap and we really did a lot. However, only from the oil products alone, estimated, we still have a massive mass flow that we lose into the air, and therefore has a massive effect on the air quality and on global heating and this and that. And what I want to say once again, this excludes methane, and methane is quite a problem. But we will go into that in the next steps. So this is what I like to show here. Then we can go into the next slide, please. The general processes that we use at tank terminals. There's many. I only want to talk about 2 because those are the 2 that we see most. First of all, we can burn the off gas. That can be in a flare, or you have quite a few processes there. Or you can actually treat the process in an actual VIU, which is also extremely widely spread. Of course, you also have scrubbers and all kinds of other stuff. But those are not as widespread and generally a lot smaller. It's for very small streams and stuff like that. So these are the 2 main points. And I want to have those in mind if we go into the next slide. I'll first talk about the first one, the oxidizer. So that means we just burn the off gas. So we get the off gas from all of the actual processes we have on the site. We add a lot of extra gas, heat it up, burn it, and then you're done. You treat everything. It's clean. However, you use a lot of gas because that's due to the fact that there's a high airflow or a high gas flow that you have to heat up, and you have to crack all of the stuff that is in this gas stream. So you use a lot of gas, meaning since you have flames, you will also have NOx, and NOx is a problem, as we all know. And if you don't know, feel free to ask questions about that. But the main problem here is we burn the off gas, we use a lot of gas, and we have extremely hot off gas. We blow straight into the air. So we don't use anything of this heat. So of course, the wisest thing to do is to ensure that you can reuse the heat that is in there. That is an option. That's also what you see in this on the right. That is an option where we can actually make steam or hot oil or whatever with all of this heat that we have. Problem being, many clients that only store products don't have a very high heat demand. And since this plant, its main goal is treating off gas, it should run 24 hours a day, generally speaking. And therefore that will only work if we also have a heat demand that is actually higher than what we can make in this off-gas treatment. So I have a question for you that you can answer in the chat if you like. And the question is, do you think, for example, here in Holland, that you can still build plants like this? That's a question. I'm curious to see what one thinks of that. So you can answer yes or no or whatever, and then and if you know, no way, that's a good answer. And I think that is the right answer. You are not allowed to install plants like this anymore, except when you make good use of all of the waste heat that you actually generate in this process. So normally, there's no way that you can build these plants anymore. You can use them when you have a quick fix issue. There are quite a few names that we work with a lot as well. So that you can do, but it starts to be harder and harder. So you need to make use of the waste heat. And if you cannot, this is no longer an option. And that's a problem because this actually works really well to clean the off gas in one step. But anyway, we will actually go on to that. The next process, that's the next slide, is the VIU, which we all know, I think, very well, generally known. And the pro of this is, of course, that we can make use of this product. So we get the actual product out of the off-gas stream again that we can then reuse. Seems like a good idea. It is. Drawback is you can't use it for every product, of course, but there are quite a few products where you can. Then there's also another problem. These plants have a hard time to meet the last thresholds that we have. So I actually did want to ask the question, do you think that these plants can meet the last threshold? But I just answered the question for you, so that's my bad. But anyway, we see a lot of problems with these plants. So we can talk about that. It might be a question that I ask in the chat now is, what are the general problems that you think clients have with plants like this? So where are they generally at fault, or where is their weak spot? Don't know whether there's anyone that cares to type. Doesn't meet emission threshold limits. It's too complicated, I see here. No good outlet for the reclaimed product. That is also a good answer. So all of the answers that are in the chat are actually right. It's hard if you look at what they generally use at a terminal and uses a lot of electrical energy. That is also true. I will have that in mind. Not all products are allowed. So all of these answers are right. So that's good that you know that. So there is quite a few answers here that are right. So we see a lot of issues with these plants. And I think the main point is that they only work well if you look after them properly, but that goes for every process. But they also have a hard time to meet the last thresholds. And one key point, once again, methane is not treated in these units. So that will become a problem down the line. I expect there's still one answer being typed. Let's see what that brings, and then we can move on then. Or if these were all the answers, then we can actually go to the next slide. No, that's it from my side for now. And back to Amol, and I will come back to you later. Thank you.
Thank you, Bart. I'm sure our attendees learned something new. There's a lot of interaction. As I said, if you have any questions, put in the chat or the question and answer. It looks like for some attendees, question and answer section is not working. Put in the chat, and towards the end, I would love to get those questions for our expertise. Now you can see one more nice graphics on the screen. By the way, if you haven't followed us on LinkedIn, please do that because we post it every Friday. We as a BM process, we started as a Friday fun because there's a lot of things are happening throughout the week. So why not we relax on Friday with some fun? And you will see all these things on our LinkedIn social media platform. So as you know, when the inspector comes knocking to your plant, most of us panic. But Judah, she smiles. And that's why we invited her, because she has dedicated her career more than 30 years designing energy efficient thermal solutions and shaping best practices across Europe. Judah, are you ready?
Yes, I'm ready.
Let's get you on the stage.
Oh, thank you very much, Amon. What a nice introduction. I would like to have this more than one time when I enter a site. Yeah, okay, let's start. So, in order to comply with low and very low emission values, pollutions has to be almost destroyed. And VOCs can be completely destroyed by oxidation. So as Bart said, methane can't be absorbed in water or can't be adsorbed in activated carbon, but they can be oxidized. So post-combustion is future safe, even if there will be limits for methane as well. This here, beneath in the slide, is the formula of the VOC oxidation. So oxidation starts at a certain temperature. But because heat is also released during the exothermal oxidation of VOCs, this is on the right side of the arrow, not only CO₂ and water vapor are produced when the pollutants are oxidized, but also energy, and that can be used. Let's have a look on the drawing above how we do this in a post-combustion unit. First, we have a VOC emitting process, for example, a loading process of a ship in a tank storage farm. We have a fan that transports the displacement air from the loaded ship to the thermal combustion plant. The exhaust air is preheated in the first internal heat exchanger. This is number 6. Yeah, sorry. Yeah, I'm sorry. The numbers are not that. Yeah, okay. But preheating is very important. We will come back later to this. So the exhaust air is preheated in the unit in the first internal heat exchanger. And in this heat exchanger, the heat from the hot clean gas is transferred to the exhaust air. The preheated exhaust air then flows into the combustion chamber. As said before, oxidation requires a certain oxidation temperature. A heater is also required to generate this temperature. There are many different energy sources that we can use. So natural gas, propane, and butane are very common, but biogas and landfill gas are also possible. Hydrogen will be available as an energy source in the near future. Electricity from a green source is already available today. As mentioned before, heat is also released during the oxidation of VOCs, and that means that the VOCs in the exhaust air are also a really important source of energy in a thermal post-combustion plant. Then the hot cleaned gas leaves the combustion chamber and transfers the heat into the exhaust air in the first internal heat exchanger. If there is still sufficient heat in the cleaned gas, afterwards, we can transfer this heat to another heat carrier in a second external heat exchanger. And it's very energy efficient to use this heat directly in the emitting process. So for example, to warming up crude oil so that it's fluid. The cleaned gas leaves the post-combustion unit via a stack. So now we have the next sheet, please. So thermal post-combustion units therefore have internal heat exchanger. They have a heat recovery, which can be supplemented by external heat recovery. They distinguish them from flares and simple oxidizers, so they are still allowed to use. Regenerative thermal oxidizers are very energy efficient units. They have an internal regenerative heat storage system with a very high heat exchanger efficiency. These units are, so to speak, the best in their class. So Amol, would you please let our audience guess how high the efficiency of the regenerative heat exchangers can be?
Yeah, sure. I'm just launching another poll. So look at your chat or your screen, you will see it. The question is, up to what percentage of internal heat recovery can an RTO, regenerative thermal oxidizer, achieve? 55, 66, 97, up to 100% as well. Okay, I got 5 responses. 7, 8, 10. Let's have a few more. Our highest was 16, so let's have at least 16. 11. All right, let's wait for another 10 seconds and then I can submit and we can view the result. 12. Okay, I think we can view the result. Whoa, you have 97% as a winner response, Jutta. Is that correct?
Yes, that's correct. So we can have up to 97%, and because we only lose 3%, the RTO can use nearly 100% of the energy containing in the VOCs. And this is special. And even more, if the exhaust air to be cleaned contains higher VOC concentrations, heat can be extracted at a high temperature level via a so-called hot bypass and can be used in an external heat exchanger. The RTO itself has a complex control and regulation system. It can be completed, for example, with an LAL measurement for the controlled dilution of the exhaust air, for example. Any dilution that may be necessary because the maximum authorized VOC concentration is due to 25% of the LAL can be part of a pre-treatment system. Depending on the composition of the exhaust air, pretreatment and post-treatment systems can be added to an RTO, for example, for inorganic compounds or droplets in the exhaust air. All types of VOCs can be oxidized in an RTO, including methane. Very important. So let's go to the next slide, please. What emissions does the RTO generate? Well, that depends. If a fossil fuel, such as natural gas, is used for the burner to generate the necessary oxidation temperature, carbon monoxide and nitrogen oxides are produced in addition to CO₂ and water vapor. We saw the formula before. But however, if the VOC concentration in the exhaust air is high enough and the heat from the VOC oxidation is sufficient, the burner can be switched off. This is also known as an autothermal concentration. In this case, no carbon monoxide and, more important in the Netherlands, no NOx is produced, as long as the exhaust air doesn't contain any nitrogen-containing VOCs. This must be added. So I think this diagram you see now illustrates this very impressively. It shows two different patterns. One with additional emissions from the burner, this is with the brown peaks, and the other one without. So if we have an autothermal concentration, we still have CO₂ emissions. You see this is a purple curve, but you don't have additional brown peaks. This is a CO concentration, and you don't have any NOx. This is the orange one. So let's go further to the next slide, please. RTOs can be used in all areas of VOC-emitting emissions. But what role do RTOs play in the limitation of the emissions coming from tank terminals, and what challenges do they face in this area? Well, all VOCs can be oxidized, but they behave very differently when this happens. So tank terminals often have to deal with a really wide range of products. And depending on the transfer and transport processes, the volume flow rates and the VOC concentrations vary greatly and change rapidly. there's a wide range of very different means of transport. Sometimes a ship is loaded and sometimes there's no ship in the harbor. And also the oxygen content and the humidity of this exhaust air can change a lot. But basically, we have to do with two main challenges. So cleaning a very highly concentrated exhaust air directly from transfer processes and cleaning the exhaust air after an REIU to ensure compliance with the strict limit values. Both exhaust air streams have their own unique challenges, particularly in terms of exhaust air pretreatment. So to delve deeper into these two tasks, I would like to ask Bar to join me. So he knows so much more about tank storage than I do.
All right, thank you, Jutta. Dankeschön. Yeah, indeed, as you said, to use processes like this in a tank terminal is a whole other ball game. Because of the fact that, you know, we don't have any fixed nice off-gas stream that is always the same and always has one or two or three products in it. It can be changing a lot and goes up and down, both in flow, in loads and whatnot. Yeah, that is a challenge. However, I think there are quite a few ways in which we can make this work properly. We have two options, indeed, as you said. And that is actually new, but we will actually get to that. So you have one of the options to use the RTO directly on the off-gas stream, even on a high load off-gas stream. You can just do that, it's not a problem. And of course, indeed, as an after treatment after an existing process, as you said. Both of them we have done, and we can go into those a little bit more in the next slide, for example. So the RTO integration option number one, that is directly on an off-gas stream. And this is, I think, new-ish. I think it's new, to be honest, because of the fact that what we have done at a few clients, one of them is being built right now, and one of them will be built within the next half year. What we see there is that we use a high load off-gas stream, and we actually act with an RTO, or actually in this case two RTOs, directly on the off-gas stream instead of the classical processes that they would have used a few years ago. And that's good news, because we feel that we can do this properly, but there's one big but, of course. The off-gas pre-treatment is critical in these things. So how do I make sure that an RTO works properly on this off-gas stream? And how do I make sure that an RTO can work in this crazy world, which is what we have there with a big flow range, up, down, this, that, left, right? That is where we have worked on quite a long time. This can work. And even the RTO has a few pros on its side there, because even at very low flow rates, it can work very well. And you can switch off the gas very, very quickly, because it can run on its own off gas if you properly make the RTO, of course, which is why we want to work with Kranz, because the quality of this hardware is where we want it to be. Now, of course, you could use gas, but as said, for example, hydrogen, we have used that. It can work. You can just use green hydrogen to replace the gas stream. All good. You can have an eRTO, also options that can also work. And then you don't use any gas whatsoever. So there are lots of options there. So also to replace classical plants where you just use a lot of gas and you have which you can't use, or critically so, there's also a driver there for clients that now have a plant where they just burn the off gas. The gas price has gone through the roof over the past years, through to what happened globally. There's some crazy shit happening, and that's why the gas price has gone up, and I hardly think it will ever come down again. So if it's not even for the air quality and all of this, it's also the price that you pay. So there's quite a few smart things here. So that's option number one. Option number two is as a post-treatment behind the VOU. So we can go to the next slide, Amol. So what we see here is a classical process, I think, that we see more and more often. That is generally where you store and transport products that you use that are actually cleaner products, let's say. You store them and all of the off-gas treatment is done, and you actually get product out of it that you can properly reuse. So a lot of clients have this plant on site since they first were built, and here in Holland we saw that on a larger scale since 2008. It started happening on a larger scale. Now, as said previously, these plants struggle with the norms that we have now. Plus, as said, methane is not treated in them. Not optimal. What can we do? Then we can place an RTO downstream. Works like a charm if properly designed. I was involved in, I think, the first large-scale project like that when I still had a real job. Let's say in 2016 for a client in Amsterdam, which is now, let's say, a client that we work for. Back then it was my job. It has run for a long time now. It has worked very well. Of course, there are a few things that we learned over time, but that works very well. So you can use an RTO downstream, not a problem. But of course, that would mean more cost and all of this. So, but I have a few things to note to that, because there are clients that say, yeah, but I have to pay more for this and I get extra hardware and I don't know whether I want that. I only do it if I have to. Of course, it makes sense. However, we have also shown that by having an RTO downstream, the previous process can run a lot easier, because it actually has to start to work less well to have enough product in the off gas for the RTO to work with no extra heat source, let's say. And if you do this properly, you can save cost. So you actually save cost by having the RTO downstream. So you not only make cleaner air, you actually save money. So there is an actual return on what you have to pay if you would install an RTO. Now, what you see in this flow sheet is that we have the option here, which we are also having done for a client as we speak, is that we not only build the RTO downstream of this treatment, but we also take on board option one for one actual off-gas treatment plant. So we actually use it as an after treatment, and we use it for treatment of a gas stream from other products. And we mix that up into one, and we use one RTO to handle both. That is a thing that just can be done. It's not a problem. But the critical point, and that's, I think, what we have to note, is that the way, at least we handle projects like this, is we want to get very far into, okay, well, what is actually happening? So we get hands-on, we go outside, we check all of these off-gas streams, we test, we want to know what is happening. And one of the critical points that we at least always do is to make a real good off-gas profile. We make a proper off-gas profile of this whole gas stream, so we properly design. And in that you can also have growth options and so forth and so on, because we too often see that, you know, hardware is built, but you have to think this whole thing through properly. Only if you do that, it will work for the long term. And then, as said, you can have cleaner air and save money. I would say, what's not to like? Now, for the RTO, of course, we've got a few options, or at least Krans has quite a few options. So perhaps you can talk us through those a little bit more, Jutta.
Mm-hmm. Yes, so we have different types of RTOs. So RTOs can be made specially tailored for the customer requirements. And as Bart said before, we are able to make measurements on the client side. So we can make first measurements and we can collect all the technical data we need to design an RTO, which is perfectly tailor-made for these clients. So here in the picture on the left-hand side, you see a huge RTO built with 5 chambers with a very big internal heat recovery system. The building in the front on the right-hand side is a steam generator. So what we do is with the ducting system on the top of the RTO, we bring out via the hot bypass clean gas on a temperature from 850 degrees. And we will feed this into a steam generator. So we have all the steam the production plant uses via the hot bypass, via the oxidation of the VOCs, the emitting process emits. So the concentration of the solvents here in the exhaust gases are so high that we are able to produce all the energy the production plant needs. A very nice thing, and the client uses this plant to decarbonize his industry. For him, it's a very big step to go further with decarbonization. This costs, of course, a lot of energy, a lot of brain energy from engineers, but we have also other plants. We call them smart RTOs because they are very clever made. These are smaller plants, to be honest, which can be transported by a lorry, and they can be on site within 2 days fixed so that they can treat the exhaust gases. So we call them plug and play because they are pre-installed and pre-commissioned on the manufacturer's side, and then they can be transported on the site where they should clean the exhaust air. The newest development from Kranz is the smart RTO with an electrical heater. So now we are able to clean gases with electricity. And if you have green sources for the electricity, it is more or less another step to the decarbonized industry, even in the tank storage. So,
Yeah, so
this is...
that's indeed extremely interesting. So you have both these plug and play options and I think the main point to these plug and play options is the fact that you can install them very quickly. So the actual work on site is not as long. So you can just actually have them built, bang them in place, start them up, and done. However, I think the one that you talked about first goes to show what you can do if you put your mind into this. You can actually make the air cleaner and save cost and also save gas, because this client previously used to make steam with gas. Now he doesn't have to. So he can actually clean his gas. So what I want to say is he can clean his exhaust air more properly, more cleanly, and cheaper because he saves cost in the end. And it is a pro for the air quality. So I think that is what you can do. So yes, there is quite a few things happening in the world. Thresholds go down. What do we have to do? Well, there are things that you can do right now. And I think it's small steps make for a big leap in the end. And it's small steps like this that you can do right now where I get a joy from, really, because that's my job. I like it. And I'm glad that we can do stuff like this. So from our side, I think that's it. So I think we're ready to answer any questions and whatnot, Amol.
Yes, I think it was very interesting, and we still have 11 minutes to go. I would like to see if there are any questions from the audience in the chat. If no, let me ask you questions and let the audience write some of them. So I have some questions to Bart, some to Jutta. Let me see. You can decide. The number one on my screen is, let's talk about RTO because I'm sure it's an interesting subject. Jutta, what's the typical price of this RTO, by the way?
I was afraid that you will ask me a question like that. So to be honest, it's not that easy. As I said before, we have customized solutions, and it really depends on what we use or what we need, what the customer need. So does the customer need a 30-meter high stack? Does he need for his exhaust because there's inorganic compounds inside of the exhaust gases? Do they need a pre-treatment, which is very special? But to give more or less a price indication for a 50,000 NOM cubic meter RTO, this is suitable for 3 bed pair VRU. Diluting everything together, installation, commissioning, so more or less a turnkey price is about 900,000 euros for an RTO. Same size, 50,000 NOM cubic meter to be treated as a smart RTO. This is a plug-and-play solutions. Is around 480,000. It's ex-works, so the transport should be priced, especially when we know where we have to bring it. And the same size, 50,000 NOM cubic meter, 3-chamber RTO with an electrical heater will be around 560,000 euros, ex-works as well.
Yeah, just to make sure that you said 15,000, so 1
15,
5.
yes, 1
Yeah,
5.
not
Yes,
50,
sorry.
because then,
15.
yeah,
Yeah,
otherwise it would
numbers
be,
are difficult. Yeah.
okay,
Sorry, thank
fair
you, Bob.
enough.
Yeah,
Yes.
and connect. There's one question in the chat, but before that, is connecting question is, I'm sure Bart mentioned that one RTO is built, which will take 6 months from now. So usual delivery time, is it minimum 6 months, 6 to 12 months? What is that?
Yes, we must be honest, this is a normal delivery time. So 6 months up to 1 year. And this is a time after we've fixed everything technically, okay? So sometimes we make a engineering before so that we really know what we have to offer. And the 6 months up to 1 year is then the real delivery time after we make the concept complete. Yeah.
All right. Good to know.
Including the commissioning. Maybe we should say this, including installation and commissioning. Yeah.
I agree. So there's a question from one of the attendees, and there are 2 questions actually, and I can go one by one. What do you need to do in the vapor preconditioning?
That's an interesting question. That really depends on what is in the off-gas. So, for example, if we have a very rich off-gas stream, just as an idea, for you, for an RTO, it can handle from, naught, so there's no stuff in the off-gas, let's say, to about, let's say, roughly speaking, 8 grams, roughly. So if there's any more in there, we of course need to dilute. So we need to stay below 25% LEL. So that is a thing that we need to do. We need to ensure that we pre-treat it in that way. But of course, you have to make that whole plant part in a way that it can actually handle all of the changes that you have on site. And for that, you need to have a clear view on what is this client actually trying to do, how does this off-gas stream go up, down, left, right, and then we can actually make this happen properly. So that is one thing, and with that I also answered the question number 2. We can't really say that like this because it actually has to do with the product and the LEL of the actual product itself. But roughly, for general stuff that we handle, 6 to 8 grams sounds like what you could generally handle, roughly speaking.
So that's the maximum allowed inlet concentration of the RTO.
Yes, so 25% LEL of the actual product in question, or product mixture, because that's what we are trying to do here. We always have a mix of many products. And we have to see, okay, how do we do this properly?
All
On
right.
the other hand, in the pre-treatment, for example, you can also have off-gas streams that have, for example, H2S in them. Now, that is an issue. How do you pre-treat that? We know how to handle that. There's lots of options there, but we also do that. So you need to ensure that you get the stuff out of there. And there might be quite a few other things that you need to pre-treat before you can properly burn the off-gas in an RTO.
Thank you. I see somebody typing the question, and we have 5 minutes. I need last 3 minutes. So I'll ask one question from my list. Let's see one more questions coming from the audience, and then we quickly wrap up. Okay, short answers. What are the common faults with VRU systems nowadays?
The faults with what? Sorry, I didn't catch you.
VRU
VRUs.
systems.
I can write a book about those. So, but I want to be quick. So feel free, by the way, after this, if you have questions, if you want to know more, give us a call or an email or app or whatnot. I'm always happy to answer any questions you might have, even after this meeting. But the faults that we see is that generally, let's say, they struggle to work properly, meaning they need care and love and care. That's what they need. And they don't always get all the love that they actually want. That is an issue. And they actually get back because then they stop working properly. The other fault that we have is that we see that what I've seen from the bat, and I've been at this stuff since 2008, so it's quite a long time, they have been, what I would say, sold as a thing that would work properly, but they are actually too small. So they are too small to start with. That's a challenge. So they will not meet the actual norms at the flow rates for which they were sold. That is also a fault that we see. We've done quite a few revamps of plants like this, and then we can squeeze more out of them. But with an RTO, that's also, I think, critical to note, you can get a higher throughput if you install an RTO downstream. That's also a critical point. So those are a few of the things.
Thanks, Bart. As I said, I need last 3 minutes. There's a question. I can see the audience name. Maybe we can answer that question to the audience directly on the email. I would like to really have a wrap-up conclusive remarks. So thank you for everybody who has asked some questions. And as Bart said, if you have more questions, please feel free to write to him. You can see his email ID is hello@bmprocess.nl or bart@bmprocess.nl. So Judah and Bart, thank you for all the answers and explanation. I'm sure some of them will definitely get in contact with you. Now, as I said, I need quick 2 minutes and I'll take you outside of the screen. Let me see if I'm there. Yes, thank you. So ladies and gentlemen, as you can see, BM process management, they do not work alone, and they have a big strength with the different partnerships they have built over the period of time, like Kranz for the thermal oxidation system, Gordium for the process risk assessment software, Oxitec air and water purification with UV and plasma, Gretec for line valve heat exchangers, and some more solutions, the Quanta for engineering services. So together, they can really deliver complete and integrated solution. Sorry, you see something else on my screen. Okay. And this ecosystem of partners helps us to ensure that our clients are not only compliant, but also future ready. Of course, if you'd like to learn more, please get in touch with Bart, and he's happy to answer more questions. And I have good news. Before we say goodbye, there is one more invitation to all of you. On November 27th, same time, we will be back with another session. And Bart wants to do actually with all the partners at least one webinar in the coming months. Of course, not in December. The topic is beyond checklist. the future of HAZOP and LOPA with artificial intelligence, AI, the biggest buzzword for now. And Bart will be joined by Jeffrey from Gordian. And if today was about reducing emissions in practice, then the next webinar is about transforming the way we approach process risk itself. So it's going to be both practical and futuristic, and we would love to see you there, and registration will be follow soon. So with this, I would like to conclude today's webinar. Feel free to visit our website, follow LinkedIn, or write us to hello@bmprocess.nl for any question that you may have. Thank you so much, and I wish you a wonderful rest of the day and weekend soon. Thank you.